Hi, and on behalf of Intel, welcome to SIGGRAPH 21. Hopefully with luck, this will be the last year that we have to do a virtual SIGGRAPH. And next year, we'll be together in person. My name is Jim Jeffers, and I lead Intel's Advanced Rendering and Visualization team. Today, I want to briefly talk about the continuing trends in 3D graphics and compute, and how we at Intel are engaged with the industry to move things forward in performance, in capability, and especially in high fidelity capability. And the good news is, you're not going to get me the whole time. We've got a couple of great guests who are going to come and talk about some of the things that they're doing to move the industry forward. So first, I'm going to talk about the ray tracing trends that we see. Ray tracing is a technique with its physically based properties and capabilities continues to grow in demand and usage, not only for graphics, but now more often for computation, especially simulation. That demand crosses many industry segments. You can utilize physically based capability that is inherent to ray tracing in a number of domains, and we'll talk about those more in a second. The next big trend that continues to grow really dramatically, maybe even more than I anticipated as we've talked about this over the last couple of years, is really the push towards open development. We're members of the Academy Software Foundation with a growing list of open source important applications and capabilities that are being delivered, as well as the many industry standards like Inari, Open 3D Engine, and other things that are coming about. It's more and more open, community-driven capability. That's really important, and Intel is strongly behind that. And then finally, specifically in the area of ray tracing and ray trace rendering, we see a ton of capability for a variety of 3D use cases that traditionally have used rasterization but are taking now advantage of the addition of ray trace capabilities, either blend it with rasterization or even more pure ray tracing and path tracing end-to-end. So what is Intel doing in the area of advanced ray tracing, and what are the advantages we think that we're bringing to play in the industry? First, as I said, openness, flexibility, and enabling the productivity through that openness, because any developer can see what's happening in the code, has a little bit better insight as to what's happening because they can access the source, and the open environments have become critical. Cross-architecture. There's a real challenge in the industry today, and we hope to work towards improving that challenge, which is the notion of a CPU backend, a GPU backend, a specialty accelerator backend. These are all slowing down progress and slowing innovation. So with our One API initiative, our platform initiatives, and solutions that Intel are looking at, one of the major goals is to kind of consolidate all that and make development easier, straightforward, cross-platform, so you take advantage of the capabilities of the whole platform. Obviously, these compute devices are good at certain things and maybe not good at others, but the platform has everything you need, and we're working towards that. Advancing capabilities, advancing technology, more AI, more compute elements for AI, supporting high-performance computing, which is a driver of computing across the marketplace. You might think that a supercomputer has nothing to do with what you're doing every day, but that's one of the areas where we innovate, and Intel is working on exascale supercomputing, is right on our doorstep, And that's an important aspect to delivering capabilities in compute that you can only dream of today. In ray tracing, there are many ways to deliver 3D information, 3D models in various forms that make sense for a variety of capabilities. So the features and capabilities and performance and memory that you use and how you utilize that on the platform is something we're looking at. And then finally, scalability. You don't always have the choice of what computer you have. Sometimes you have great choices. Sometimes you have access to a data center, a cloud, but you might only have access to a laptop. What we're trying to bring is the scalability to take advantage of the full capabilities of whatever platform you touch. So that's part of our holistic view. So let me tell you a little bit more about our platform approach. Again, we want to take advantage of platform-wide capabilities from the XPUs that are on your platform, CPUs, GPUs, other accelerators, to more importantly, every day is memory, the size of memory, the memory's capabilities, its speed. All these come together to give you a platform view of what you need to do. In particular, Optane persistent memory I see as a huge boon that's just beginning to be able to be taken advantage of. In particular, on a per dollar basis, you can get much more memory, just a bigger memory footprint, and everybody wants more memory, especially in the 3D arena, where memory and data footprint really indicate either the complexity or the fidelity that you can deliver, as well as practical things like long-running systems do fail. But if you have it in persistent memory, you can get fail-safe rendering and other elements to restart your process as opposed to lose a day, lose an hour. All these elements we're trying to bring together for you. Cross-architecture I mentioned. Cross-vendor capabilities we're supportive of. Intel, of course, we believe we make the best products and the best platforms, and we're going to deliver you the best experience. But in order to deliver that, we need broad support across vendors. So for instance, we've been enabling Apple's M1 ARM for many of our software products. We'll talk about that soon. We're just the leaders in advanced ray tracing. I'll talk about that a little more in a second, but features, capabilities, breadth of needs driven by the market, that's what we're about. Of course, because of that, we've been able to create a broad ecosystem that's not Intel only, but many, many partners who deliver and utilize our capability and our platforms to give you the best experience. Again, the flexibility of one API and an open approach to the market gives you all the tools you need and the insights you need, and the feeling that if something goes wrong or you're challenged, you at least have the open environment to look into what the issues are, and in Intel's case, work with us to solve those problems. And we have the industry-leading capabilities for rendering. Broad sets of capability in our rendering toolkit. Just to give you a sense of where we see things and where we've been as far as Intel's focus on you, on the developers, on the users in the community that the developers serve and your applications serve. If you look at a typical GPU backend today, these are the kind of features here. Some of them are really cool features. They're very good. And you might think, okay, I've got everything I need. Well, the answer is, with a rendering toolkit, you get this breadth of features, and all these features are on their way to being mapped very soon to Xe GPUs for cross-platform capability. No transistor left behind, as I said. So all these capabilities we've already built. We haven't been constrained by a particular environment. And in fact, the CPU has given us the ability to do very flexible and a very wide breadth of capabilities. Well, we already have the code, and in one API, we can map it directly to Intel GPUs coming out very soon. Okay, I talked a little bit about Intel One API Rendering Toolkit, and this is the mechanism that we use to put together all this great capability, taking the input from the market and delivering it to you in a easy to use, consumable manner, certainly as a developer, and then those developers hopefully map that to the applications and you folks who are using it out there. Rendering Toolkit is built to be general and flexible. So it's not just film. It's not just scientific visualization. These are built to be core libraries and capabilities and components that can deliver what's needed for multiple domains. As I said, film, animation, visual effects, heavy use of Embry, and very soon OpenVKL you'll see used more and more often. Scientific visualization, OpenVKL, Embry, Open Image Denoise, 3D architectural design. You want to see what you're going to get, right? If you're going to design a building, whoever's funding that design, they want to see what that building is going to look like. Cars, automobiles, our work with Bentley and VW to show you and enable more virtual uses so that this virtual world can bring you realism. And then finally, games. I'm sure most of you are involved and interested in the gaming industry, AR, VR. Intel One API Rendering Toolkit enables that across the industry, and with our goal of no developer left behind. We provide a plethora of components. We're going to continue to add components that are best for the industry. Exactly what's in the toolkit. Our goal is to really enable the highest performance within the scope of highest fidelity rendering. It's heavily being used for compute as well, because much of the simulation operates in a 3D realm, and ray tracing provides the physical base capability for that. We want to provide the most flexible, cost-efficient development capability, one API to deliver the performance and capability based on the platform components you have. And then we want to enable you to access all of system memory, which includes GPU memory, in a way that's consumable, high performance, and allows you to have your vision, your work, pop quickly. Components are Intel Embry. Intel Embry is the tried and true geometric kernel rendering library used in many renderers. Open Image Denoise, the best, highest fidelity rendering, or denoising rather, on the planet. Open Volume Kernel Library, you'll see that used much more often in the coming days. And then Intel Osprey, bringing it together with components based on it, like Osprey Studio, which allows you various mechanisms to create workflows for visualization and high fidelity path trace rendering. Osprey for Hydra, a USD delegate. Can't stress the importance of USD, particularly to the film industry, as an interchange and development environment. And then finally, we're not about all ray tracing all the time. Intel OpenSWR for platforms that don't have all the GPU capability that they might need. OpenSWR provides data centers, cloud environments that have a compute-centric view. They still allow visualization and rasterization to happen. Okay, what's been happening lately in Rendering Toolkit? We haven't been resting on our laurels with the Embry Awards. OpenVKL is a really strong volume environment, and the use of volume rendering is growing dramatically. We now have motion blur support for VDB, mostly for film use, but we see VDB now being used often in scientific visualization as well. As I said before, Apple M1 ARM support is now in Embry. It's in Open Image Denoise, and now we support it in OpenVKL in the upcoming release in this quarter. So that will also support Apple M1 ARM capabilities and other ARM platforms. We are market focused. We are market driven. We continually bring features out that either one or more film studios, design houses ask us for, and we keep that up, and they're available in open source quickly. And then finally, we're really thrilled that the Intel ISPC SpinD compiler with all its vector capability is being mapped to the vector capabilities of our upcoming GPUs, and we have betas of that, and it is going to be available very soon for use and mapping of your existing ISPC code to our Xe GPUs. Broad ecosystem capability. I mentioned that already. Here's a little bit more about that. These are just some of the hundreds of applications and companies that use Intel Rendering Toolkit. You may not know it, but you're very likely using it in any of your creative or gaming capabilities. Somewhere you may be touching Rendering Toolkit. And again, these are all the industry leaders that we work with to deliver the best industry highest fidelity capability. And we're thrilled to have the Autodesk Arnold renderer becoming one of our key customers and partners for the wide delivery of capability, particularly for film and television, visual effects, and animated development. And here to talk about what they're doing is Frederick Servant. He's Autodesk's Senior Software Development Manager, and he's going to share their direction and how upcoming releases of Arnold are going to be improved in a variety of areas, but in particular with Open Image Denoise.
Hi, my name is Frederick Servant. I look after the development of the Arnold renderer at Autodesk. Arnold is a production renderer that pioneered path tracing in VFX and animation, which is now commonplace. For this achievement, we received an Academy SciTech Award in 2017 with Sony Pictures ImageWorks. Arnold is designed to handle complex rendering challenges in VFX, in feature films or episodic, in feature animation, also in music videos and commercials. It's also now used in motion graphics and product visualization. Arnold is also used to produce non-photorealistic renders, for animation and visualization in particular. This is also known as toon shading. This is really important for our Japanese customers producing animes. Here are a few examples of what you can achieve with a toon shader. Some of our users reported slowdowns on many core CPUs, and the Intel engineers helped us optimize the performance of the toon shader spectacularly, as you can see, thus achieving interactive speeds on CPU with toon shading. Following up on this success, we decided to collaborate next on the integration of Intel's Open Image Denoiser. We had strong demand to integrate Oidin from some of our customers who are praising its speed and quality. Arnold already ships with 2 denoisers, but we thought it would give our users an interesting additional choice, Oidin being deep learning accelerated and running on CPU. In Arnold 6, we had recently introduced a new post-processing framework called Images. We use it for 2D post effects such as glow or color correction, and it's the perfect place to integrate Oidin. The implementation was very easy, and we were very happy with the results. The quality and speed of Oidin really helps with interior scenes. Because we can denoise so quickly, it can also be used in IPR. These are real-time recordings of interactive renders without and with Oidin denoising. In conclusion, I'd like to thank Intel for these amazing contributions to Arnold. We are really excited about the ongoing collaborations with the Arnold team at Autodesk.
Wow, thanks, Frederick. We're really thrilled to be working together with you and Autodesk on the upcoming improvements and advantages in the Arnold renderer. So we've been very honored to receive some awards this year for Embry, in particular, our kind of longest running heart of Intel rendering toolkit. In particular, we received a Technical Achievement Award from the Academy of Motion Pictures Arts and Sciences. We're thrilled and honored about that. And then very recently, Eurographics at the Eurographics Symposium on Rendering, also known as EGSR, gave Embry an award for being pretty much the best software package for graphics in the last 10 years. And we're thrilled to accept those awards. And we also want to thank all of you who contributed in whatever way, either helping us drive the improvement in your renderers or utilizing Embry for the performance for your films and capabilities. So we want to thank all of you for that help in bringing this, and we all share this together. Thank you. Okay, I mentioned the key trend of open standards and the various consortiums and foundations that are being formed, and Intel is at the heart of this. My team and I are thrilled to be part of many of these initiatives, particularly the Academy Software Foundation, working on USD. Inari, which you should keep an eye out for, is going to be a new rendering standard in addition to DXR and Vulkan, kind of at a different level. We're also thrilled to very recently be part of the founding group of companies on the Open 3D engine and the Open 3D Foundation. And I want to bring on Royal O'Brien, and he's going to tell you more about what's happening and the exciting things happening with the Open 3D Foundation.
Thank you, Jim. We're really excited to be working with you and the other partners along with the open source community on the newly released Open 3D engine. Now, why is having an open source project like this important to the industry? Well, let's talk about what's been open sourced. For starters, this is a complete cross-platform, end-to-end solution that was designed around modularity and flexibility to be used for just about anything. This means that almost everything is a module, including the new high-quality AAA PBR-based renderer that supports DirectX 12, Vulkan, and Metal. You'll only need to consume what you want to use, instead of having to take the entire engine just to do your project. So you'll find out one of the key pieces of open source is that the speed of innovation is not limited in any way by a single company. And the features being created are actually based on actual customer needs. So it becomes more interesting when you find out that some of these needs can be served in multiple industries. This means that whether you're in games, automotive, AI, robotics, simulation, or film, and it opens up collaboration in ways that may not have been possible before. Because the open source project that we have here was actually designed with kind of a flywheel in mind, instead of just putting source code out and seeing how the community will take it. So in other words, what it starts out is you have kind of the open source community with a technical side of it that works with partners like Intel and others, and they help drive new technologies, which in turn, that helps create new products. And these new products actually open up new markets that create more participation, which in turn creates more innovation back in the technical community. So you can see this kind of goes over and over, and this growth cycle allows it to grow, but not just in one vertical, but in multiple. So if we take that and keep that in mind, let's just say we take the Intel Osprey renderer, which is also an open source project, and it's scalable and portable. And the fact that it's a ray tracing engine that's kind of high performance, high fidelity visualization that you can use with common CPUs that are found in laptops and desktops and even in cloud service providers like AWS. It can be plugged into the engine, kind of as an extension to give developers the ability to create solutions that can use this incredibly accurate ray tracing renderer for interactive applications. So if you think about it, you can have multiple renderers that can be plugged in and plugged out or used together at the same time. And so you don't have to worry about, well, is the color space matched or am I changing anything? Because it's all using the same system and the same output. So it makes it a lot easier for you to change or build a pipeline that's very consistent. And the other part of this is that working in open source, everybody contributes to the open source project, which is under the permissive Apache 2 license. And as a result, everyone winds up benefiting from it. So no matter whether you're coming from automotive or film or robotics, some of those shared formats and structures can actually carry over and be reused as a result of it. Well, thank you very much for having me as a part of this, and I really appreciate the time. Thanks a lot.
Wow, that's really exciting. Thanks, Royal. It's really great to partner with you and the rest of the Open3D Foundation on the Open3D engine. Look forward to contributing to that and seeing some of the great results and applications that come from that over the coming years. I want to briefly talk about what we've been doing in the industry, especially in the research and academic realm. So at Intel, we founded over the last several years the Intel Graphics and Visualization Institutes of Excellence. Note the XE on front. These groups of really strong universities in 3D graphics, AI, rendering, areas that we're highly interested in, and as a community, we are working closely with these teams to enable them to do the research necessary to move the whole industry forward. Much of their research actually comes back into Rendering Toolkit, Osprey, Embry, OpenVKL, OpenImage Denoise. Briefly, Charles University, they are working on sun, sky, detailed models. How do you model and deliver realistic sky models with the right reflections, the right light? Obviously, ray tracing is all about light. They're doing some great work in that area, as well as very interested in driving AI light transport and other utilizations of AI in graphics, which I know we're all looking forward to figuring out the best way to take advantage of AI. Texas Advanced Computing Center, the #1 academic computing facility in the world, along with Kitware, are partnered together to help us deliver new features, new capabilities to the #1 visualization app in the world, ParaView. And then finally, University of Tennessee is working closely with us on web-based and ease of access to the masses of high-fidelity rendering and computational capabilities. So these are at the forefront of the best 3D visual research, and we're thrilled to be partnered with them. Coming now to the end, I just want to give you a quick view of some of the work we've done over the last couple of years, as well as our other partners in media and film. So take a look, have some fun. Wow, even though we've been involved in working on these projects, I still get a thrill whenever I see those videos, and I'm really honored to be, part of this industry and to work with all of you out there on such great projects and such really cool technology. So thank you for that. If you want to learn more, I kind of gave you a quick overview of what we're doing at Intel. If you want to learn more about details about what we're doing, take a look at the resources on the screen, and you can find out much more about Intel One API. Should be very interested in that project. It's going to have an impact on you in the future. So in summary, Intel's thrilled to be part of this industry. We are really interested in driving open environments in a collaborative way to deliver the best capabilities that developers can use to then deliver solutions and capabilities to the graphics artists, to the game developers, to the product designers, to the scientists out there. And we want to be your partner in doing that. So to recap, sky's the limit. The use and demand for high quality, high fidelity visuals seems to be never ending. We want to deliver the best capability you have. We don't think that proprietary bifurcated programming models are going to be sustainable in the future. You can't have multiple back ends for specific products and make that sustainable and deliver the innovation that you need to do, as well as the fact that it's open allows collective wisdom to deliver features and capabilities faster. So we think the open environment is the way to go. We want to be the industry's partner in delivering the highest fidelity 3D capabilities and compute out there. Reach out to us, talk to us. We're here to be your partner in delivering the best capability. And then our delivery vehicle for much of it is Intel One API Rendering Toolkit. Check it out. We're going to keep making it better. We're going to deliver it on coming GPUs, and we're really excited to have some of the things in the lab that are coming soon. And then look, in the very near term, you're going to hear more and more about Intel's new capabilities, new platforms. Please keep an eye out for that. And with that, thank you for your time. I wish you to have a great time at this virtual SIGGRAPH 21. Again, we'll see you in person next year. Thanks and have a good day.